Hello and welcome back to another festive coding session with Mr. Jacob. Today, we want to tackle the next in our advent of languages, where we strive to implement each day on the 24 first days of December the same program in a different language. And the program that we usually want to implement here, or this December want to implement, is something that outputs this tree more or less, either as an ASCII tree, or we already have other implementations where we do this graphically because the language was a graphical one. So today we want to do that in Swift. So that's actually kind of Apple's more or less open source language, which is used for newer macOS applications there. And we don't want to implement that as a full blown application within the Apple framework, but we want to do this like we are always doing here, only using the language. So what I have done here, I've created only a simple make file after I have checked that I have the Swift compiler here, which simply takes our source file, the Hello Xmas Swift, which we will create in a second, and compiles it to an Hello Xmas executable. That's actually everything. So as always, I've just prepared the development environment, so to speak. And we can now do something like create our hello xmas.swift file. And as always, there is the caveat that usually, if you are doing a greater and bigger Swift project, there is actually a package manager built into the Swift ecosystem, which you can use to create all kinds of different environments and compile them. But here we only want to kind of compile one file, so why not? Um, we can essentially in Swift just start by writing out our code. So I could do something like print hello Xmas, and this would actually do fine, at least I hope. Uh, and if I now execute that, we get hello Xmas. So that's actually kind of neat. We don't need any sort of main function or something like that. We can simply start out there. I think we don't even need the semicolon. No, we don't need it. I think it is optional in Swift, but that I'm not 100% sure about. So let's see how we can actually implement this stuff in Swift. And what I want to do is, as Swift is usually used in a quite object-oriented way, um, I want to do this in an object-oriented way, even so it's not that needed for what we want to do. So first of all, I guess, as always, let's copy out our little example tree here, which we have seen just a second ago. Let's copy that into our file here. And let's quickly paste that there. Let's fix it up a little by removing the unneeded spaces. And let's add a comment there. So now we have our tree there. Maybe we should do it like that. Looks most likely a little bit neater. Come on. So we can actually remove those there. Okay, so now that's essentially kind of what we want to print. And I guess we will do that by maybe defining some sort of class or object for it. There is actually the struct for it. There's actually the difference in Swift between structs and classes. And structs are kind of always used for value data, where a struct is always copied on assignment and not referenced. A class is more like a traditional class where we will get back a reference to an instance. And if you set that, for example, to another variable, it will just set the reference and not copy the whole thing value by value. And there are a little bit more differences, like, for example, a struct can't have a deinitializer, so a destructor, so to speak. Only a class can have that, and there are other nuances there. However, I think that we want to implement this on a struct because it is essentially what we want to do. So we have something like struct, maybe Xmas tree. And yeah, you simply define a struct like that. I'm not sure why this is now indented strangely, but yeah. Then within our struct, we can actually go ahead and define properties within that struct. And we want something like, for example, the groups. So we prefix them with private because everything in a struct is by default public, which makes sense if you think about it. As I've said, it's kind of the value container in Swift. So everything that you put in there is usually public. But we want our number of groups here, which should be an integer. So we define it like one. Yeah. Okay. So we have now defined that. We don't need, and that's a neat little thing, we don't need to define an initializer specifically because in Swift, all of this given, yeah, values of a struct are automatically given an initializer. So it's an auto-generated initializer, so to speak. So what we can now do here is something like let tree equal xmas tree, and we tell it that we want kind of, I don't know, maybe 6 groups or something like that. And now it should have actually created an xmas tree. And as you can see, we have a little bit of a weird syntax here going on how we specify that. Actually, all the different arguments to a function in Rust always have, not in Rust, in Swift, sorry, have a so-called external and so-called internal identifier. And you are usually specifying an external identifier when calling something, though, so that it is kind of a little bit more natural to read. That is the idea behind it. We will see that in a second when we are creating our first function. So um, or maybe we should talk about that because I'm not sure that we will create a function with arguments there. So yeah, we could do that by talking about a little bit of our functions. We have those internal and external identifiers because this is a really neat thing in Swift, and I'm not sure that we are using it here in this example more than what we are doing here. You have something like, you can, for example, define a function using the func keyword, and we could call that, we could do something like create new tree, for example, and we could give it the the groups here. So we tell it that we want groups as an int, and it will return an Xmas tree. So what we now do here is simply just return an Xmas tree with groups. So this would actually turn out okay. This should essentially work. Let's see that it does create new tree groups 6. So this should actually work. Let's see that it does. Make we actually have this neat little thing called make def here, which actually can handle that. And I have forgotten to specify the var here. You always need to specify a variable here as var inside something like, for example, this is this Christmas tree. So let's try again. Now there's something else wrong. Error Xmas tree initializer is inaccessible due to private protection level. Okay, I guess I can't make this one private because I want to set it from the outside. That kind of makes sense. There is most likely a way that I don't know to make it accessible, like you can set it in the beginning from the outside but not then later on. However, as you can see, this now works. Okay, so now let's make this group private then. However, as you have seen, we have this groups thingy here specified when calling our function. And to be precise again, we don't need this. This is just an example to show you how to define that. However, what I can do is we have an external and an internal name. And what we have here now is this is now both the external and the internal one. So this is actually what we are using on the outside and on the inside. I could, for example, do something like groups, and I call it internally, I call it n. So what's that now mean is, or what that means is that on the outside I specified like this during calling, and on the inside it's actually using the n identifier. And as you can see, it still works the same way. You can tell it that you don't want an external identifier by using the underscore, and then I don't need to specify that here, so that I now actually can call it like that. If I, however, not specify it really like this specifically divided thing, but only using both an external and internal, like you would usually know from the syntax in other languages, it will actually not compile this. So it will tell me that it needs the argument label groups there. So this is essentially really enforced by the language. So let's maybe do it like that. just to see, just as an example of internal and external argument labels. I'm not 100% sure how they are actually called. However, that is something that is quite neat in this language, and you can either like it or you can hate it. It's up to you. So now let's start implementing our Christmas tree. We need some sort of function here. So let's maybe create a function called, we could call it draw, maybe. Why not? So that we can actually now on our tree call a function called draw. And I'm beginning to think that this is some sort of maybe convention that my VI wants to enforce there on the source code. I have no idea. Maybe the brackets are defined in this strange way in Swift. I have until now only written a little bit of Swift in Xcode, but not a lot. So I'm not sure how this actually needs to look. Okay, so now we have our draw function. So as always, we need to first kind of print our groups. So maybe we do that by calling print groups. And we can simply do that and define another function in here called print groups. And we could make this function, for example, private. And this is then another function, and this now prints something out. What the heck? What was that? Let's print something, maybe hello group or something like that here. Just to see that this actually works out and that it does what it should do. So as you can see, I have removed the groups here. Of course, I need them again because I have an external identifier there called groups. And as you can see, it's printing hello group. So you can simply call that. You can specifically tell it you want to call that on self. The same thing is true for variables. So I could just use groups within our functions here because it is in the same context. I could specifically reference them with self if I have some sort of shadowing going on or stuff like that. But usually, or in most situations, you don't really need that self. You can simply call that. So I guess this print groups is a nice thing there. So let's quickly do that. So we need a loop first. So we do something like for I in, for example, here 0, 2 groups. However, we want that half open, so we want that exclusive the end. So we can simply tell it that we want to go from I to from 0 to less than groups. Otherwise, we could simply do it like that. Then that would mean it is inclusive and incorporates the groups, and we should be able to do something like that. And so we have actually this loop now, which prints our groups, and maybe we could do something like print the group in there. However, yeah, I guess we should do that. So we need some sort of spacing now for our string. I guess we need, as always, the spacing of those spaces here that we have in the beginning. So a group, as always, is one of those sets here which are going to create this zigzag shape. We need the spacing in front, and we already determined a couple of times that the spacing in front, so let's call that maybe front spacing. I think we need to call that var. The front spacing is actually the number of groups that we actually have completed minus the current iteration, so minus I in this situation. And then we have this inner spacing, which would be the one which is between those thingies here, which is the inner spacing is essentially I times 2, at least for the first of those lines. For the second of those lines, we will see in a second. That's a little bit different. So we now have defined those variables, and so we need to somehow repeat spaces. And actually, we can create a string. So we can easily create a string struct here, which is called a string, and it has a couple of nice, neat little parameters. For example, it can do repeat. We can actually do something like repeated, I think it is. and we tell it that we want repeated, wait, no, repeat, and then then the character or the string that we want repeat, and then we give it a count, and this should actually maybe give us a string. We will see in a second if it was repeat or repeated, which actually repeats the space this amount of time, and we simply create a string like that, and we can do the same thing here with our second string here. And now we simply need to somehow print that between our characters of the tree. So what we can do now is we can call print, and we can do string interpolation, which in Swift works by using the whoa, I didn't want to scroll up there, the backslash character. So you do a backslash, and then you put that in between parentheses. So what we can now do here is we can actually do, I guess, evaluate most of the Swift code here. So we want the front spacing here. Then we want a slash, and then we want the inner spacing. Then we want a backslash, and then we want um, a new line. However, I don't think we need the new line there because I think print line creates a new line. I guess we will see in a second. So let's see if this actually does what we wanted. And yeah, as you can see, I'm wrong. I said it that I want to give it the repeat. However, it tells us that it is repeating actually. So expected repeating is quite neat that it can tell us that. So Swift actually has a really nice error messages most of the time. So let's check again. And as you can see now, it actually gives us this. However, it tells us that the variable was never mutated and that we could change it to let. So var is actually a mutation or not a not read-only variant of that. So let's just use let, which is the read-only variant. Like in Rust, for example, the mud keyword, Swift has something like that. So we now have essentially the first level of all of our groups. So we need the second level, and the second level has a little bit of a different spacing, and we should be possible to actually shadow those variables here. This should actually work. We will see in a second if it does. So what we need now here is we need groups minus I, and we need one less, and this should actually be I plus 1 times 2 now. And let's see if we can run this. And yeah, we can't actually shadow that. That's kind of interesting. So let's maybe then do a var here nevertheless, and let's just define those again. And now, as you can see, we have our tree structure there. So now we have a private print groups function. So let's maybe create a private func print divider or divider. Never know how to divide, or never know how to actually do that. And it seems really that this is some sort of coding convention that I'm completely missing there when writing Swift with the braces. So we want the divider. The divider actually is kind of easy. We can simply do this one here, and we can do the interpolation. And now I'm curious if we can actually put that in there, because I've never tried that before. So this should actually be the repeating of the minus character, and it should be the amount of groups times 2 plus 2. So this should actually maybe do that. And now we need to, of course, call that print divider. And let's see, okay, that actually works. So this can actually be, I guess, a more or less arbitrary Swift code. So that's actually quite nice. So let's do a private func trunk or print trunk. And we can more or less get that one, and we will do something like let trunk spacing, which would be the number of groups. So and we want we want a string repeating the space character count groups here. So let's get that, and let's remove my semicolons, which we don't need. Good thing they are optional, so it doesn't complain if I create them. So let's actually remove those thingies here, and let's do the trunk spacing plus 2 pipe characters, and that we do 2 times. And then we add print divider here and call that, and open that, and wait, no, not print divider, print truck. Yeah, and now we have our Christmas tree there. Okay, so I think we still have a little bit of time to create maybe a little bit of ornaments within our tree. So I guess we could do that by defining something like var ornament, and this would be a string, and I would put in there maybe the star ornament character. I'm not sure. Or we have actually we could do this as an array. This actually defines an array ornaments. So let's maybe quickly get them from. We already had them somewhere here in our what was it, 03C? No, it was 04 Python, I guess. We had them in our Python implementation, didn't we? So perfect. We can kind of take them from here and put them here to do a quick thingy here about our possible ornaments on the tree. Just a neat little bit of Unicode characters there. And now we should have those ornaments. And what we now want to do is kind of create this string. So let's maybe do something like private func print ornaments. And we could give this thing, for example, an argument like we could do print ornaments probability, and that would be a double, for example. Yeah, and it would not return anything, but it would print those thingies then. And what we need definitely is we definitely need the account. So what we need here are the numbers. So width, we need the width. We need to know how much or how many ornaments space there is. So the spacing to be set. So, and we could make this, for example, we could give this a default value so that we can say, okay, usually with 20% probability. Okay, that would be kind of nice. So now let's see. We now need to replace our inner spacing with exactly that. So print ornaments, or not print. We need generate or get. Maybe we could call that make ornaments. Make ornaments with would be, what did I say there? It would be I times 2. And yeah, we are not changing the probability here. So let's do that same thing here as well. This would be make ornaments with would be I plus 1, and we need that times 2 there. And now we need to obviously create this. So I guess we create a simple starting point here for our ornaments, or not ornaments, let's call that output. And this is an empty string in the beginning. And then we do something like for I in 0 to the width. We now do something like if our now we need a random value between 0 and 1, and we are actually doing this by using the double type here and calling on the double, which is kind of a struct here, the random function. And I'm not 100% sure. You can do something like between, or I'm not sure that this actually generates something between 0 and 1. We might need to specify that. However, probability, we would assume that we can do this now. And if this is the case, then we want to do something like output, and we want to add one of the ornaments. That's actually easy. We can do something like random element, which we can call on collections actually. That should actually give us a random ornament here. However, as always, we need to take the width thingy into account a little bit different. So maybe we should do it like let I equal let I equal 0, and let's do a while width. I know while I is less than width, we will do that because in this case, when we add an ornament, we actually need to add one add 2 to the width, because our ornament characters are Unicode and they are wider than normal characters. So we need to take this into account, otherwise the spacing will be broken afterwards. So come on, and else we simply do output plus equals an empty space and width. No, not width, sorry, I. We need to, of course, increment the I plus equals 1. And let me try and fix this. We have formatting there, even though it might be correct. And in the end, we want to return output. Yeah, this should maybe work. Maybe we need to specify. I'm not sure. I guess we need to specify something like we want random between 0 and 1 here. So maybe we will see. Okay, this does not work. What did I do wrong? Okay, so left side of mutating operator isn't mutable. I is yeah, okay, that's of course a problem. I get that. So let's make that. Let's make that a variable, so a mutable variable thingy there. Okay, so cannot convert value of type string to specified type string. Yeah, that makes sense as well. I'm not sure if if it can actually infer the type. It seems to be able to infer the type. Value of type string has no member random element. Doesn't it? I would have thought that this actually exists. Maybe I wrote it wrong. That's actually interesting. What's the problem here? Default value. Force unwrapping port execution is if optional value contains nil. Okay. I guess this returns an optional then. So, however, this must work, I guess. Unexpected non-void return value. Yeah, exactly, because I specified no return value here. I should have done that. So it will return a string there. And as you can see now, it is printing out ornaments. However, the formatting here is a little bit broken because we forgot one little thing. We need this probability to match, and we want it not to be the last character. So if I is still less than with -1, and this thingy works, then we want to do that. So let's see. And now we have a proper Christmas tree with ornaments that we can compile. And now we have Hello Xmas here, and we can call it over and over and over again. And we have a neat little Christmas tree with ornaments printed to our console. So yeah, I hope you had fun playing a little bit with Swift here, even though I'm far from being an expert at Swift. So please bear with me if I've done something wrong here. And I hope you will join in again tomorrow when we are tackling another language in the advent of languages here on this channel, until we have reached the 24 days of December and are finally there. So yeah, I hope you will join me again, and please give the video a thumbs up if you liked it. And don't forget to hit the subscribe button if you want to be informed in the future when there are new videos on this channel. So I hope to see you in the next one. Bye!